Welcome to chapter 3. So in chapter 3, we have 4 sections. Chapter 3 we see is radian measure and the unit circle. And so we're going to introduce radian measure in this first section, and that's our goal for today. So I've mentioned radian measure before. And so what is the idea behind it? It's a different way of measuring an angle. And so far, we've basically just done everything in terms of degrees. So as you can see here, we're going to introduce radian measure. And then we're going to talk about conversions between degrees and radians. So far this came up because when I did my introduction about using calculators to calculate trig functions and even inverse trig functions on a calculator, that we said everything's in degrees, so make sure your calculator is in degree mode. Well, now you might want to have to switch back to radian mode sometimes, or make sure that it's in radian mode if we're working in radians instead. And so once we have this other way to look at the measurement of an angle, instead of 30 degrees, we'll have a radian measurement of what would be the same as 30 degrees. You then want to do your trig functions for angles and radians. Just the way you would do sine of 30 degrees, you're going to want to do sine of some radian measurement as well. So again, just to be clear, we're just changing the units of measure. So an example of what that means is like I can say, all right, I want to measure the distance from this point to this point. And maybe, just looking on my silly little screen here, maybe this is like 3 inches. So that's a way of measuring how much distance there is there. But you could use other ways of measuring distance. Like I could use feet. Well, there's 12 inches in a foot. So if I have 3 inches, that's 3 out of 12, or 1/4 of a foot. Or maybe I would use centimeters. Maybe this comes out to be like maybe 7 centimeters. That's probably not right, but something like that. So you can measure the exact same thing different ways. You can measure distance in feet, inches, miles, centimeters, kilometers. You can measure time in seconds, hours, minutes. These are all just different units for measuring the same thing. So now if we have an angle that we're going to measure, then we can say, well, this is 25 degrees. I know that's kind of 25 out of 360 for all the way around, stuff like that, for how many rotations that is. It's a way of measuring a gap between 2 lines forming an angle. And so radians is going to be another way to do that. It measures an angle in a different way. It's a different type of unit for measuring angles. All right, so having said that, let's take a look at it. An angle with its vertex at the center of a circle, and you could always attach an angle's vertex to the center of a circle in this way, that intercepts an arc on the circle equal in length to the radius of a circle, has a measure of 1 radian. So what the heck does all that mean? All right, so what they're showing here, an arc on the circle equal in length to the radius of the circle. An arc on the circle equal to the radius. So they're saying whatever the radius of the circle here, if you had that same length, this is the R is the radius here. If you take that radial length and you wrap it around part of the circle, so that the R of the radius of the circle matches the length of the circle there, then that forms an angle of length of 1 radian. I've always thought that's just a silly way to define this. It's so confusing. But nonetheless, it's a valid way to define it. But they're trying to say what 1 radian would be. So I think there's a simpler way to do it. And so let me, while this is here, imagine thinking about this a different way. So I'm going to make some changes here and say you could also think about this way in case this is helpful. So if we say that the radius is 1, notice that most of the work I've been doing in this class, I've been trying to reference everything to a unit circle where the radius is 1, because I think if you reference everything that way, it just makes things easier. So let's say we had a unit circle and we have some length theta. Then the length of this arc that you get on the unit circle with angle theta, length of this arc, and the arc is this part here, this curved line. So the length of that arc is the radian measurement of the angle. So imagine you have a unit circle and you have some theta. Well, you could take sine of theta, that would be the y value of the point at the end of that angle. You could take cosine of theta, that would be the x. Or you could get the arc measurement up to that particular point, and that would be the measurement of that angle in radians. It's the radian measurement of that angle. And so the simpler way to think of that is to think of some common examples and how we would figure out what is the arc length. So as soon as you talk about what the length of a certain part of a circle is, we're going to base that on what the length all the way around a circle would be. So again, if I have a unit circle, then you may recall from some early possible like a geometry formula class or algebra class that there's a measurement called the circumference, which is the distance all the way around the circle. And their circumference is 2 times this number pi times whatever the radius is of the circle. So if the radius is 1, then the circumference is equal to 2 pi. Because we plug in a 1 for r and you get 2 times pi. Now remember, pi is just a number. 3.14159 something. So if I double that, I would get like 6.283, something like that. So the distance all the way around a unit circle, the circumference around it, a unit circle, would be approximately equal to 6.28. So if the radius was 1 meter, then the distance all the way around would be about 6.28 meters. If the radius was 1 foot, then the distance around would be approximately 6.28 feet, etc. So 2 pi is the exact value when the radius is exactly 1. And so if I want to have a part of the circle, because I have an angle theta, so I'm getting an arc on the circle that's not all the way around, I would want to know how far around it is to know what that arc length would be. So for example, let's go up here. If I have a theta angle and in degrees it was 180 degrees, that's halfway around the circle. So that would mean that in radians, theta would be 1/2 of all the way around the circle, which is 2 pi, or 1/2 of 2 pi. And if I multiply 1/2 times 2 pi, I get just pi. So the radial measurement of the 180-degree angle halfway around the circle, the radial measurement of this theta is equal to pi. So pi is going to show up again and again and again when you're using radians, because it's this weird irrational number, 3.14159, etc. But you get 2 pi when you go all the way around the circle. So you get 1 pi when you go halfway around the circle. And so if I cut that in half again, I could imagine that I'm now doing a 90-degree angle. If I do a right angle, well, then my arc length there would be 1/2 of the 180 that we just did. So then the angle for a right angle would be 1/2 of pi, or we refer to that as pi over 2. So 1/4 of the way around a circle, on a unit circle, the arc length would be pi divided by 2. So that's the name of that angle. So 90 degrees is the same as pi over 2 in radians. 180 degrees is the same as pi in radians. And all the way around the circle, the full circumference of the circle would be the same as 360 degrees. And all the way around is the circumference of a unit circle, which is 2 times pi. So the way you can think of what the radian measurement of an angle is how, when you look at that angle on a unit circle, how far around the circle did you go? How much of the circumference did you get in your arc when you opened up that angle? Was it 1/4 of it? Was it half of it? Or was it some portion of it? And so when we have radians degree, you can write 1 radian, meaning I went around an arc length of 1. But the friendly angles that we're used to, like for our nice triangles, 30, 60, 90, all of those radian angle measurements will be something involving a pi, something involving the number pi, like pi for 180 degrees, pi over 2 for 90 degrees, things like that. Questions so far about any of that?
Nope.
Okay. So the same way you got used to common and popular angle measurements like 90 degrees, 45 degrees, 180 degrees, was really thinking about how much of the circle that was, how much of a full rotation that was. And so we can do the same thing with the radian measurements, and just remember that all the way around is 2 pi. But now that we have this definition, we can have this formula to convert between degrees and radians. So the first thing it says is if we want to, we can multiply a degree measure by this number to convert to radians, and we can multiply a radian measure by a number to convert to degrees. So we have 2 things going on here. So here's a simple way to think of it. We know that 360 degrees is all the way around. And that's the same as 2 pi circumference of a unit circle. So if I want to know how much 1 degree is, well, if I have 360 degrees on the left, and I want to know 1 degree, for 1 degree measure, I can find out how much radians that is, because I would basically take the 360 degrees and divide it by 360. And if I do that to both sides, then on the left side, I get 1 degree. And on the right side, I get 2 times pi over 360. 2 divides into 360, leaving 180. So I get pi divided by 180. So that's where this comes from. So this conversion means if I have 1 degree, that's pi divided by 180. So if I have 10 degrees, I would multiply that by how much 1 degree is to see how much 10 degree is. So that's why you multiply any degree measure you have by this number, and that converts it into radians. So 5 degrees would be equal to 5 times 1 degree in radians, which is 5 pi over 180. Or if I simplify that, 5 goes into 180 36 times. So that's pi over 36 in radians. So this gives you a little formula, but it's good to kind of understand and think about how this relates 1 time around the circumference of a unit circle with 1 time in rotation of 360 degrees. And if I wanted to go back the other way, I would multiply by the reciprocal. They just flip this fraction upside down, because if I started with having 360 degrees was equal to 2 pi radians, well, if I wanted to know how much is 1 radian so that I can have something to multiply by radians, then I would divide both sides by 2 pi. Then on the right side, I get 1 radian. And on the left side, after I simplify, I get 180 degrees over pi, which is what they have here. So they come up with these ways where they get a fraction which allows you to convert from one to the other. All right, so then we got to kind of get used to these. And I think there's a table up here that kind of summarizes some things. Let's see. Well, first we have some examples. So let's say we try an example. So they say, all right, convert each degree measure to radians. So if I have 45 degrees, as they do in this first example, and I want to convert to radians, I multiply by the pi over 180 number. And then after I simplify, because 45 goes into 184 times, then that becomes pi over 4 radians. And we can also help, for those who like to think graphically, to visualize what's going on. There's 45 degrees. We know that halfway around is pi, and 45 degrees cuts the halfway around into 4 equal size pieces. So that's pi divided by 4, because pi is halfway around and 45 degrees is 1/4 of a semicircle, of half of a circle. Because there's 45, there's another 45, there's another 45. There's 4 45 measurements to add up to 180 degrees, which is halfway around. And we know that pi is where you're at when you go halfway around. So if I cut that into 4, I get pi over 4. So the formula, of course, will do that for you, but it's good to try to think about it and kind of visualize it so that these things make sense as well. It'll keep you grounded when you're just coming up with a number by some formula, that the number makes sense. And so for each of these 3 cases, they just take whatever the thing is and multiply by pi over 180, and then that gives them a value for radians. And you might You might have some multiple of pi and leave pi in your answer, like pi over 4 or 3 pi over 2 with a negative. Or if it's some decimal number, then when you do this, you might actually have the calculator use its version of pi with a bunch of decimals so that you can get a decimal approximation of how many radians there are as well. The difference would be that when you have pi in your answer, these are exact answers. And whereas this is an approximation because we rounded off to a decimal. Questions, comments, discussions about that? All right, so let's give you guys a chance to try one of these just to see if you can do it. If you've got a computer calculator ready or something, you want to do some things like find the pi symbol. So this gives us a chance to explore this a little bit if you haven't already. And so let's say we wanted to convert 30 degrees into radians. And see if you could imagine coming up with the exact value for that. And then, of course, you could type that on a calculator to get a decimal approximation as well. But try to come up with the exact value of that, meaning that there'll be some pi, multiple of pi kind of a thing in your answer. So give that a try. And if you're willing to share what you got, great. But either way, give it a try just so you're feeling that you're trying to apply this formula and use it correctly.
The number, the C is 249.8 divide 180 multiply 3.14 something, right?
Yeah, so because that's multiplication and division, you could do that in a different order. So you could take 249.8 and divide by 180 and then multiply by pi, or you can multiply by pi first and then divide by 180. There's a little flexibility there.
Okay.
And you should get the same answer in any of those permutations.
Yes.
It's definitely good to practice these things because then little issues like order of operations or how do I do this on my calculator, you can kind of work out all these details. Anybody have a suggestion for the solution for 30 degrees, what that would be in radians?
Pi to 6 radian?
Yeah, so we'd say pi over 6.
Pi over 6.
Yeah. All right, so let's follow through with that, but that's exactly right. Thank you for that. So what I would do is, as they did in these examples, I would take this number to convert it to radians. I would multiply it by a pi divided by 180. And so if I do that, I can do a little simplification as a fraction. For example, 180 can be factored into 30 times 6. And then I can cancel the 30 in the bottom and in the top. And that's why we end up with a pi in the top and a 6 in the bottom. And that would be the measurement in radians. And we could approximate this if pi is like 3.14159, a little bit more. Then if I divide that by 6, I would get something like 0.5, like a half a radian. But pi over 6 is the exact correct value. And a calculator would always give you whatever decimal accuracy you wanted after that. Questions about that at all? Okay. So going the other way, if they give you something that's in radians, you could then convert that into degrees by multiplying by 180 over pi. And notice now when they're giving you something in radians, when they give you nice exact values, it's usually got some multiple of pi in the answer already. And so if you take something with a pi in it and you multiply by 180 over pi, you can see that the pi's cancel out here. And then you would do some other canceling as well. Like if I divide 4 into 180, as we saw before, that's what gives you the 45 degrees. And if I multiply 45 by 9, that's how they got their 405 degrees. So it is good to do some of these by hand. And then, of course, use calculator when helpful. Like down here, in this bottom case, they gave you radians in a decimal format without any pi multiple. And so that means that you're not going to leave pi in your answer here typically. You're just going to use a decimal approximation for pi. And then you can do that on a calculator to produce a degree measurement by multiplying by 180 and dividing by pi. And then they also noticed they used the approximation symbol, the squiggly equal lines there, because they had to round off because they used a decimal approximation for pi. All right, so we've introduced this new type of angular measurement, radians. We've talked about how it's defined and how it relates to common angles in degrees, and then even had formulas to convert from radians to degrees or vice versa. So here's a rule of thumb. If no unit of angle measurement is specified, then the angle is understood to be measured in radians. And the truth is that, as we saw when we were looking at the calculator settings before, radians is typically the default. Now, if you talk to most people in the real world who have some idea of what an angle measurement is just from common use, most people are used to degrees, 15 degrees, 10 degrees, 5 degrees above the horizon, rotate 20 degrees this way, things like that. Most people aren't used to using radians unless they've had this definition and some math classes to discuss it and things like that. And so being able to go back and forth is very helpful just in interpreting things in the real world. But definitely as you get more and more used to radians, you'll find that people who are doing trigonometry or even other math types or calculators in general, the default for angle measurements is actually radians. And that's why this pi symbol becomes more and more popular the farther you go in math. So here's a nice little table where they've done some conversions for us. Some of the things we already saw, but look, like we already saw over here, 30 degrees is pi over 6. 45 degrees is pi over 4. Well, 60 degrees, since that's twice 30, it would be 2 times pi over 6, which gives you pi over 3. 90 degrees is pi over 2. That's one of the first ones we did. 180 degrees is where you get a nice even pi, etc. And then in each case, they give you a little approximation of the radians measurement too, because sometimes that little pi symbol can seem confusing to people. The thing to remember is that pi is just a number. And so you can always use that number with an approximation to get an idea of what you're talking about. So pi divided by 2, that's about 1.57. 2 times pi is about 6.28. It's a number. So this table is a good place to sort of see the common angles. You can see if we're working with a 30, 60, or 90 degree triangle, or those kind of things. All these measurements that we've been using more commonly, they're all included on this table for conversion into the radians measurement. All right, so now that we've summed up the idea that you can express angles different ways, now you can express them in radians or degrees. Well, here's a nice diagram on a circle for a visual impression of what these actual angles look like and what they would be labeled. And so they go all the way down to a whole bunch of different angles, 30, 45, 60, 90, and then they keep going with those reference angles all the way around the circle, so that this is a very nice picture. I think when I remember when I was taking trig, I just kept looking at this picture many times. I would always go back and use this to convert between the two. because you could also visually see what's going on. Okay, so the main, a lot of times the degrees, radians has two things in it that really bother students until we get a little more used to them. One is this pi symbol that shows up everywhere, this weird irrational number. And the fact that, of course, you have all of these fractional amounts of pi. So all of a sudden you have denominators and common denominators and canceling common factors and all of this math stuff from arithmetic where you have to work with fractions, and everybody hates fractions, right? And so definitely there's some effort that has to be put in there, but I guarantee it will be well worth it for your work in Trig if you can really get used to these radian measurements as soon as possible. And I think this table is a great place to start in that direction. All right, well, if we then have this other way to express angles, we then want to imagine taking the trig functions of those angles. And so one of the ways to do that is to convert them into degrees. So for example, if I'm looking at their number b on the screen here, I could say, all right, what is sine of 3 pi over 2? Well, I could try to go back up and say, well, what was 3 pi over 2? Oh, here it is. That's when you're all the way down here. So that's this angle where you ended up there. And then now that I know where that angle is, whether I call it degrees or radians, I can figure out what the y value of the point on the unit circle would be there. Since this is straight down below the origin, and this is the unit circle, on that point, the y value is -1. So that means that sine of 3 pi over 2 is -1. You can get to that angle using 270 degrees. You could get to it using 3 pi over 2, especially if you have a common circle here so that you can just look up the radian measurement without having to convert. But instead, they used the little conversion formula here, or they didn't in this case because they said, well, 270, that's more obvious. But as they did in some of these other examples, you could use the conversion formula so that you end up in degrees. And then maybe it would be easier to do in degrees. But pretty soon, anything you could have done degrees, you can also just do immediately using the radian measurement if you have a nice table like this to see what it would be. And that's it. So I did want to also, however, take a look at how on a calculator, you're going to want to make sure you can remind yourself how to do degrees and radians, and how you can use that to help you get used to the difference between these two as well. So actually, before we go here, let me take a look at that on my screen here. Okay, so if I pull up like just a Windows calculator, then as you recall, we have this degrees here. And so in this case, this has already been set to be in degrees, and we have trigonometry here. But if I click on the degrees, then it switches over to radians. And notice now I've got a pi button here. So it changed the calculator for me. If I go back to degrees, here's the pi button. And so we can say, oh, well, if I was in degrees, I don't really need the pi button. But when I go over to radians, that's why the pi button is there. So if I'm in degrees and I hit 30 degrees, and then I hit the sine function, it'll take sine of 30 degrees. And we see that that's 0.5 or 1/2. That's the height of the y value of the point on the unit circle at 30 degrees. If I instead switch over to radians, now if I put in 30 and I hit the sine function, well, now it doesn't give me 1/2 anymore because it's doing a radian measurement of 30. Meaning I went to the unit circle and I kept going around the arc length until I had gone around 30, which would be like 5 trips around the circle or something. And so that's why we have to be careful that we're set in the right mode, because you might have thought and you put in 30 degrees, but it's thinking radians. And again, on this calculator, there's a teeny little r there to remind you that it's thinking of this 30 in terms of radians. So if I wanted to do 30 degrees, as we saw on our circle, the 30 degrees is pi over 6. So instead I would go pi, and there's the decimal version of pi, and then I would go divided by 6 and see what that gives me. So this is the radian measurement of 30 degrees because it's pi over 6. And now when I go take the sign, because I'm in radians of pi over 6, then I get the 1/2 again. So if I want to do like cosine of 60 degrees, I would switch to degrees, hit 60 and hit cosine, but 60 degrees is pi over 3. So if I'm in radians, I can just go pi divided by 3 and then hit cosine, and I get 1/2 because that's the x value coordinate for 60-degree angle. So here you can kind of see that you can play with trig functions in radians or in degrees, pretty much on most calculators. And being able to use both comfortably will be helpful because depending on the problem that you're working on, it may be in degrees, it may be in radians, or you might want to convert. And having a calculator able to help you with that goes a long way to making you comfortable with doing those kind of problems.